So the award's typically based on something noteworthy like research and development that's been done, like reliability and robustness, a novel application of the technology, or just something that's noteworthy related to, say, the scope of a deployment. So this year, the award is going to Alcoa, and Chester is going to receive the award today. So Chester, on behalf of our governing board and our members, we'd like to present this award to you, the Excellence in Automation Award. And thank you for the nice presentation.
I guess this time I'd like to ask Paul and Mark to come on up. We'll hopefully get a chance to guys in the presentation. We appreciate that. And hopefully you might have a few questions you'd like to ask panelists and presentations. So I guess I'll open it up to anybody in the audience with any questions that they'd like to ask. Sir, if you could just also announce your name and...
I'm Daniel speaking. I'm with Anderson Howler. My question is to Chester about the wireless part.
There you go.
Thank you. You mentioned safety showers. Those safety showers were not monitored before?
Yes. To answer your question, the answer is no. In the old days, some of our plants are like 50, 70 years old. And so in the old days, the safety showers had no monitoring. Our new installations, it is mandatory to put monitoring devices on the new installation. So we're retrofitting. What we're doing is retrofitting old safety showers. And in the process of doing that, it's pretty expensive when you talk about the area that we're covering.
Follow-up question to this. Are you guys connecting the new retrofit, are you guys connecting that to the SIS? Or are you guys just connecting it to the DCS?
Connecting it to the DCS.
Thank you. Oh, you could... thanks, Bob.
I agree with that, Chester. Great presentation. Two questions for you related to the wireless side of things. From a business cycle perspective, how did you determine the size or the bandwidth and kind of sell that to the business for the investment? Was it a top-down push that they were asking for? Was it a bottom-up push that you needed it? And then the follow-up question to that is, in terms of that network, do you know when you're going to run out of room on that network? Do you know kind of what those capabilities are and what's going to be your next push, or what's the next limit you're going to run up to?
Okay, so it's bottom-up, right? Most of these projects are usually recommended by the field engineers, and we basically present a business case to management and convince them that, okay, based on the benefits that would be derived over the next few years, especially in the direction that the technology is going, with everything being connected, connection of things and connection of people, that having a wireless network would be justified. Your second question, I'm not capable of answering. More management and technical. And at the beginning of my presentation, I gave credit to the guy who really should be here, Robert Polinelli, and I can give you his contact so you can talk to him or you can send your question to him. If anyone else in the room, I don't know.
Anybody else want to take that question on by chance?
About bandwidth and capacity?
Yeah. Grab a...
determine how big to start out?
Is it like that?
How big to start out with? Well, okay. A lot of times we look for early or low-hanging fruits. So we start out and we demo the benefits to management, and then we get approval to offer more coverage. So initially in wireless, we did one process area. Let's say, okay, we did digestion. In our plant, we have 4 major process areas: digestion, clarification, precipitation, calcination. And we have a raw materials area and a port. So we select an area where we could basically prove the entire concept, that if we had an implementation of wireless here, you know, these are the advantages and these are the benefits that we can derive. So we start there, prove it to management, and when they see, especially the rapid deployment, or they see the reduction in the amount of capital that is being requested to install an instrument, then money talks. And so, yes, they see the benefit right away.
Yeah, Andre, you wanted to add a few?
Yeah, so the ISA 100 is a deterministic network, so it has time slots and message lengths. And you can mathematically compute what the maximum is on that. So typically, when you're designing the network, you look at the application and how frequently you're reporting and what the message sizes are. And you can get a sense of what you're consuming as you're building.
Okay. Anybody else have any questions for the, go ahead. Do we have the?
Thank you. Question for Ruben. You mentioned about the best speed and the best economy as far as the fuel consumption and what the captain should be running at. Is this like a recommendation that is given from the system to the captain, or is it like implemented and controlled?
Yeah, that's a good question. And we're not tied into any of the vessel systems, so we don't control any sort of throttle settings. So what it is, it's the captain has the ability to select a button on our display, and then that takes him through the steps of how to get to that best economy or best speed state.
The follow-up question, do you see any other system where it can be implemented, such as airplanes maybe, or oil rigs where you have generators, diesel generators running?
Yeah, I mean, basically any system or any, like you said, rig or something that has generators that it's consuming, with the measurement, with using the Coriolis meters, you can measure that. We have the infrastructure already in place and how to collect the data and how to distribute that data. So absolutely, that's something that we'll be looking into.
Anybody else? I'd like to ask Paul if I could. I know that I've been looking at the subsea market over the last number of years, particularly the multi-phase flow metering market, and obviously lower oil prices took its toll, and I think and one of the biggest challenges they had even before lower oil prices was that the cost of these projects was so prohibitive. So I'm very excited to learn about the MDI-NS initiative, because I know standardization is something that was severely lacking in a lot of those projects. And if you could just sort of maybe expound upon how, given the recovery in oil, hopefully the continued recovery in oil prices, you think that technologies like OPC and others will help, achieve that issue of standardization?
The sort of the key thing we saw with MDIS, unofficially I got reports from some of the operators that, the testing time that they had on these systems were, order 6 months or longer. So, you needed 6 months of testing time. When they went to using a standard interface that you could pre-certify the interface beforehand, the testing time went down to 6 weeks. And then when you started adding object models, so standardized object models, so that you didn't have to worry about the mapping and the, oh, did I transcribe all the numbers right for my Modbus interface and get everything mapped correctly? Testing time went down to 2 weeks. So massive savings in budgets for everybody, on every side. You still have the, profit margins on things. The the company's still doing very well. So what we're seeing is that we're getting more and more demand from the drilling industry. So I work with the IADC, so that's another drilling organization, and with DStats, which is a surface drilling one. They're all trying to standardize the drilling rigs, the production systems, because they want to have the savings. The fact that if you have all the data coming in using a standard protocol, it's so much easier to collect it. You know, most drilling rigs have 6, 8 vendors on them, and they all have their own way of collecting data, their own buses, their own things. And the operator wants the data from all of them. So he has to, you know, have half a dozen different interfaces sometimes collecting data. And they want to standardize all that into a single interface. And most of these groups are picking OPC because of the information modeling capability we have. So we can take whatever data they come up with and map it and provide a standard way of getting the data back.
That's great. I think a lot of operators are going to benefit from that,
Yeah.
certainly.
And the people that implement it actually get benefits too. Because it's easier on them from a testing point of view. They can usually charge a little more for the instruments that have it, and the operators are willing to pay because it's so much less on the back end that, you know, pay a little more and you get a higher profit margin out of it. Everybody seems to win.
Right.
So.
That's great. Well, if no one has any I have a quick question for Mark. I know that based on the research I've done at ARC in a previous life, that you guys have a pretty full suite of solutions, sensors and switches, and I noticed that at least 2 of our speakers have mentioned using your solutions. I'd just like to see how you guys are seeing, you know, sensing and in terms of adding intelligence into sensing in the future. If you may have currently some smart sensors today, and where you see things going as it relates to oil and gas specifically, but in any case, any general comments you'd like to make?
Yeah, we're seeing customers start to use the devices and the data more and more, as you heard today. And one thing that we've done recently across our entire platform is implement what we call heartbeat technology. So it's where the devices are self-checking themselves based upon factory conditions. When the devices leave the factory, they're calibrated, and there's certain bandwidths set within the devices that as they get installed in the field, they're consistently checking themselves to monitor their own health, so they can advise the end users how the device is performing in the field, if there's any buildup or corrosion going on in the device itself, if the device was installed incorrectly. So it's one step that we're taking to go above and beyond to help the devices to bring more data and more value to the field.
That's great. Great. Thank you. All right, we'll give the audience another chance to add some questions. Otherwise, I think I might ask one of Andre, because I know this is the 3rd time in my session, and I'm very grateful for all these great speakers every year. And, I'm sorry, go ahead.
So I have a question for Mr. Rashid. You mentioned that you had 2 different radars, one of them time domain, the other one being frequency domain. So how did you standardize on the deviation between the 2? Like, is there a threshold that you say, okay, if it's deviated at, I don't know, 25 millimeter, that's acceptable versus 100 millimeter is not acceptable, something like that?
Okay. Currently, we are based on deviation based on the whatever, when the setup is correct, we will look at the numbers. At this moment, we cap it at 200 mm as an alarm. But sometimes we saw 50 mm, sometimes we saw 100 mm. So this is actually a work in progress. So basically try to further trim the deviation. Maybe another 1 year I'll come again and explain the results.
Well, I haven't seen anybody giving us the hook yet, so if you guys are willing to stay in there, I am too, because the buses won't leave for Discovery Cove until, I'm told, probably 6:40. I'm saying 6:30 just to get people there, and I'd hate to have someone blame me for missing the bus, but so we're not going to go that late, but we certainly do have some time. So,
I do have one question for Ruben as it relates to data and data flows. You know, obviously you've got a fleet and you've got 5 or 6 meters. I don't know how many on each one, and you're collecting the flow and the temperature and the density. And and all those parameters, how did you decide how rapidly to collect that data? You know, obviously, if you're going up through a satellite uplink, there's some cost and some bandwidth to that. How did you right-size the data set to get value out of it, but to not overwhelm yourself with the data?
Yeah, good question there. So you're right. If there's a, depending on the type of vessel that we have, we can have a tremendous amount of meters, and then additionally, when we also measure tank levels, we have level sensors that come in. And so we have all that data that comes in. So what we've standardized and what we've done is we take 1 minute averages, so 1,440 records a day, and we put that, you know, it's all stored on the database on board, and we compress that file and send it over every 24 hours. And then we also provide near real-time data, so about every 15 minutes, we send a short burst data with just a small amount of data. This is how many engines are running. Here's my current consumption, that type of information.
Okay, in the interest of time, I'm going to give each person just maybe, if they want, or they can choose to pass, it's up to them, maybe one or two key takeaways I'd like the audience to go away with. Obviously, this is going to be videotaped, so obviously more people will be viewing this in the future. So kind of think of that in mind. And if you have any, if you want to pass, that's fine. But if you have, you know, one or two takeaways that you'd like to give us, that would be great. Otherwise, we'll be soon to wrap up. So feel free to, if you want to start us. Or...
My major takeaway would be that in the future, going wireless and utilizing wireless instruments and sensors would be a cheaper way of mounting field instruments out in our location, especially in brownfield applications.
Great. Thank you.
And so there's something that's always stuck with me. There was a quote that I had in one of my slides, and it said, this is from a client of ours, and he said, "You can't manage what you don't measure." And so that's kind of just stuck with me, and that's something that we see as a truth. You know, now that we're being able to measure this and collect this data and analyze this data, we're just seeing the results, where before people just didn't know in the maritime industry what these vessels were consuming and how the fuel is being accounted for.
Okay, my major takeaway is on the importance of this overfill protection system. You can see 2005, big incident, Banksville, 2009 in Puerto Rico, and yes, I should explain that one. Thank you.
I think as a manufacturer of field devices or edge devices, as some call them, our key takeaway here is the importance of the data that they can provide to end users. We talk about all the different ways to get the data to end users, but the device itself has to be properly manufactured, properly installed, commissioned, set up in order to get the accurate and reliable data to the customers.
Critical, absolutely.
Yeah, so what I'm seeing with the deployments, the maturity level on using wireless has accelerated, and it's moved forward faster than I expected. So we see policies like what Alcoa has, where they're evaluating wireless and wired. Almost all the deployments of sensing technology is a combination of the two. So wireless isn't going to replace wired, but it's a good augmentation. I'm also seeing the cost of these sensors go down. Back in 2008, when there was the ISA 100.11a committee, Wayne Mangus, who was a co-chair of it, kept talking about lick and stick devices, cheap wireless devices that you could install quickly, maybe disposable. And I see folks in the ISA 100 ecosystem in our membership building these things, matchbook size gateways and that sort of thing, and very, very cheap.
Thanks, Paul.
So from the OPC Foundation point of view, what we're seeing is that these days the sensor technology, the technology down low is growing tremendously, but the requirement these days is not just for the data, but they want to see it as information. So you want to be able to group the data, package it together, and move it up to the IoT world, so to the cloud and the enterprise world. And key thing here is that you want common infrastructure for moving the data, and you want it as information, not just data. You want to package it together in appropriate ways, appropriate information models. And that is the trend. It's moving very fast, actually, much faster than many people realize even. So, you know, in the future, there'll be a lot less in the middle. The data will go directly from the sensors to the cloud. So in some cases.
Fantastic. Well, first of all, I'd like to thank the audience for hanging in there with us. You guys have been tremendous, and your questions have been greatly appreciated. And I really like to give heartfelt thanks to my speakers and my panelists.